Hey everybody, so we're going to talk about subtracting mixed numbers where you have to borrow from the whole. So the fundamental thing you have to understand is this. When we have a mixed number like 2.5, you have to know that it is equal to or the same as, we have this half, but I'm going to ignore that right now. We have this whole number 2, and so the whole number 2 is made up of 2 halves, that would give us 1. Another 2 halves, that would give us 2. So this whole number 2 is equal to 2 over 2 plus 2 over 2. Now we're done with the whole number. We're going to go back to the proper fraction. So we have the half. And so what I'm trying to show you here is that 2.5 is the same as 2 over 2 plus 2 over 2 plus a half. I'm going to do one more, just really quick one. Same idea. We have 3 and a third, but I just want to talk about the whole number 3. The whole number 3 can be rewritten as 3/3, which gives us 1. Another 3/3, which gives us 2. Another 3/3, which gives us 3. And then remember, we have the proper fraction sitting here. So we can see that 3 1/3 is equal to 3/3 plus 3/3 plus 3/3 plus 1/3. Now I'm going to add an additional part to that. 2.5 is equal to 2 over 2 plus 2 over 2 plus 1 over 2. So you could write this as an improper fraction, which is 5 over 2, or 5 halves. Now the reason I did that is you can see you have 2 halves plus 2 more halves plus another half. 2 plus 2 plus 1 is 5. So, same idea here. I have 3 1/3, which is equal to 3/3 plus 3/3 plus 3/3 plus 1/3. Or I can write that as an improper fraction with 3/3, another 3/3, another 3/3, and another third. 3 plus 3 plus 3 is 9, plus 1 more is equal to 10/3. So, here we have a mixed number. Here we just have it expanded into proper fractions. And here we have it written as an improper fraction where the numerator is bigger than the denominator. This is a mixed number. It is a mix of a whole number and a proper fraction. This is the stuff expanded. And here again, we have an improper fraction. 10/3, the numerator is bigger than the denominator. Now, the reason that is super important is what we're going to do today is we're going to need to borrow from the whole. So, I have 5 2/5 minus 3 7/10. Now, exactly like what we were doing before, the first step is you have to find a common denominator. Now, I know with 5 and 10, 10 is a pretty simple denominator. So I am going to change 5 2/5. I'm going to double the top and double the bottom into 5 4/10. Now, I don't need to change anything here, but I want to rewrite the problem. So at this point, you can basically ignore this. Now, I can take 3 away from 5, no problem, but I need to borrow from here. So you can see I have 5 4/10, but I can't take 7/10 away from 4/10. So I am going to change the whole. I had 5 wholes. I'm going to trade in one of those wholes for 10/10. Remember how we talked about how we could break these things apart. So when I take away this whole, I traded it in for 10/10. So this is equal to 4 14/10. I added the 10 to here. So now I can do the problem. You can rewrite the whole thing if you want. Most of you would probably just look here and here. But again, what I did, I had 5 4/10. I showed that that is equal to 4 14/10. Now I can do the problem simply. 4 minus 3 equals 1 whole. 14/10 minus 7/10 equals 7/10. So this is my answer. We will do a couple more examples. So over to here, I have 8 1/4 minus 2 4/5. Same thing. I have the exact same problem. I need to find a common denominator. I know with 4 and 5, I list the multiples, that it's going to be 20. So to make this 20, I multiply by 5. I multiply this by 5. 8 1/4 is equal to 5/20. Down here, I'm going to multiply them both by 4 to make this 20. So I have 2 and 16 twentieths. And now I need to subtract. But again, I have this same problem I had before. I can't take 16 away from 5. It's just not possible. I don't have enough. So I've got to borrow from the whole. I had 8 wholes. Now I'm going to have 7. Now, that whole was made up of 20 twentieths. So when I trade in that whole, I put the 20 over here. So I can now rewrite this as 7 and 25 twentieths. And then again, I'm going to rewrite it just to keep it a little neater. I'm simply writing the same thing here. Now I can do my problem. 7 minus 2 is 5, and 25 twentieths minus 16 twentieths is 9 twentieths. So my answer is 5 and 9 twentieths. All right, so this next one, I would like you to try on your own. And we're back. I always enjoy saying that. So again, I need to start with a common denominator. I am going to make my denominator 9 by tripling this and tripling that. That gives me 3 and 3/9. 1 and 1/9 stays the same. I don't need to borrow. 3 minus 1 is 2. And 3/9 minus 1/9 is 2/9. I am finished with that problem. Now we have 2 and 1/8 minus 3/4. So I need to have a common denominator. I have 2 and 1/8. And I am going to turn this into 1 and 6/8. Now we have the problem where we have to borrow. So I can't take 6 away from 1. So I need to borrow from the whole. I had 2 wholes, but I'm going to trade that in. And with this whole, that one whole was equal to 8/8. So I am now trading in that whole and sending those 8/8 over to here. So if I send that over, I now have 1 and 9/8. Again, I'm taking the whole, the 8/8, and I'm trading that whole in so that I can move it over here. So I now have 1 and 9/8, and I'm going to subtract 1 and 6/8. 1 minus 1 is 0, and 9/8 minus 6/8 is 3/8. You can leave the 0 or not. The important thing is the answer is 0 and 3/8.